You might look at that problem and go, no way, I can't do that. I can't handle that. Yeah, you can. It's actually really simple to solve this exponential equation. Okay, we got to figure out what value of x makes these two equal. But one thing I noticed right away is that my bases match. So you might be intimidated the second you see this problem, but it's actually very simple to solve. Okay, because our bases match, we can just say, go away, get gone. Sayonara, see you later. So I'm going to take 3x, I'm going to bring that down. I'm going to set it equal to 7x minus 2. And the reason I can do that is because my bases were the same. So because the bases are the same, we are allowed to just remove them. They cancel each other out. We're left with 3x equals 7x minus 2. Now this is just solving an equation with variables on both sides. So we should know how to do that by now. We're going to say minus 7x cancels minus 7x. Now I've got negative 4x is equal to negative 2. And then I just divide by negative 4, cancels, divide by negative 4. X is equal to a negative divided by a negative makes a positive, and 2 divided by 4 is 1/2. So we have now already solved for x very quickly, very simply. Now, these problems aren't always going to be this easy. I'm going to give you another example right here where we have to do a little trick. We got to do a little mathematical thinking here, figure this stuff out. So let me rewrite one more problem for you where our bases don't match. Then you can understand how to go about a problem if 5 was there, but we had a different value over here. Now, this is the point where kids that felt like they had an understanding of it get this problem and they're like, well, what am I supposed to do now, right? Because 3 and 9, those don't match. So what are you supposed to do now? If the base here is 3 and the base here is 9, we can't just bring down z is equal to z plus 5 because that's not the case. We've got to make a matching base. Oh man, how can we make a matching base? When I see a 3 and a 9, my brain right away says, are there any tricks I can play? And the answer is yes. 9 is really no different, I'm going to write this over here, no different than 3 squared equals 9. 3 times itself makes 9. And because of that, I can make a base of 3 like I have on the left side. I can say 9 is really just 3 squared. And then take this information, the exponent's expression, and put it right outside, like so. Now, one thing we know about our product property, our exponent properties, is that if I raise one power to another power, I'm basically just multiplying these. So I've got a 2 here and a z plus 5 there. I'll put parentheses around it because it's an expression, which means we're going to have to take 2 and multiply it by z plus 5 using the distributive property. This is going to be equal to 3 to the power of z. Nothing has changed over here, but look at that. We went from 3 and a 9 to a 3 and a 3. That's good news because now what we can do is we can say 3 to the power of 2, also raised to the power of z plus 5, is going to turn into 3. Well, what's 2 times z? 2z. What's 2 times 5? 10. Now I've got this information written out, which allows me to now say, because my bases are the same, like on the previous example we just did, let's just remove those bases of 3. This is now equal to z equals 2z plus 10. Solve this equation with variables on both sides. We're going to take away 2z, cancels, take away 2z. Now I've got negative z is equal to 10. We'll divide by that hidden negative 1, divide by that hidden negative 1 to cancel it. And now we've got z all by itself. It's going to be equal to 10 divided by negative 1. So z is equal to negative 10. So just because your bases don't match up, ask yourself, with the larger value, can you break that down? Can you simplify it to a base that would match? And if you can, then you can use this trick right here to solve any exponential equation that you need to. Hopefully this makes sense. Study hard and good luck on your upcoming test.